Hello everyone, this is Rajiv Sunaki, Department of Civil Engineering, Jain Polytechnic, Belgavi. So we are back with the next lectures remaining in Unit 1 of RCC, that is Introduction to RCC. So in this lecture we will be covering totally 4 parts, that is lecture 3, 4, 5 and 6. So let's look at the content in these 4 lectures. First one is differentiation between limit state method and working stress method. Second one is limit state method of design. Fundamentals of limit state method. Introduction to stress block parameters. Neutral axis, moment of resistance. So first coming to differentiation between limit state method and working stress method. So limit state method, it is a plastic design method, whereas working stress method, it is an elastic design method. In limit state method, the stress in the material is allowed to go beyond the yield limit and enter into the plastic zone to reach the ultimate strength. But in case of working stress method, members are designed to never go beyond their elastic range. It means that in limit state method, the member shows the deformations or a signal before failure, but in case of working stress method, it is not the case. The structure fails suddenly. Here in limit state method, it is a strain based method where it is linear, and in working stress method it is stress based method. And limit state method, it is non-deterministic method. Working stress method, it is deterministic approach. In limit state method, partial safety factors are used for design, but in working stress method, factor of safety is used for allowable stresses. Next is ultimate load method. So this method is also known as load factor method, as it is based on ultimate strength when the design member would fail. In this method, factors are taken into account only on loads or load factors. The method of ultimate design of a structure is defined as a method which limits the structural usefulness of the material of a structure up to ultimate load. Now coming to introduction to stress block parameters. So you can see a figure here where the first one is section, the rectangular section of a beam, second one is strain, and third one is stress. So here we are considering a singly reinforced beam. Why singly reinforced beam? Because the reinforcement is provided only in one direction, that is in tensile zone. So what we are getting after determining stress block parameters are, we are determining moment of resistance. Ultimately we are determining moment of resistance. So here you can see a beam of width B and depth D, and 4 bars, that is steel, are provided here. And now coming to the strain diagram. So in case of a rectangular beam, the strain is linear, but in case of stress, so you can see a recto-parabolic curve. The meaning of recto-parabolic curve is, so 47% is rectangular and 53% it is parabolic, a curve that is above the neutral axis. So here you can see in the stress curve, you can see an arrow which is indicating C and another arrow which is indicating T. The C is the compression force and T is the tensile forces. where this compression force and tensile force, they form together to form a couple, and finally we get what? That is moment of resistance. So you can see 0.0035, 0.0026. so these all are the values of strain which are determined. So as I told, see here you can see X is depth of neutral axis, B is the breadth, D is the effective depth. So after substituting all those values, so ultimately what I told, we are getting moment of resistance with respect to concrete, that is 0.36 FCKB, and secondly moment of resistance with respect to steel, that is 0.87 FY AST. Next is neutral axis. So here in the figure you can see a section of a beam of width B and depth D, and in the center you can see an imaginary line, dotted line, that is the neutral axis. Means the meaning of neutral axis is the above part is compression and below part is tension. So whenever the loads are applied on the beam, that center part or the dotted line, which is called neutral axis, the stresses in the neutral axis will always be 0 in that portion. So the stresses where the portion in a beam where the stresses are completely 0, that is called as neutral axis. So as I told, it divides the section into compression and tension zone. Next is moment of resistance. So what is moment of resistance? Moment of resistance is nothing but the resistance offered by the beam against external loads. Thank you.